Okay, thank you for your introduction and hello from my side. This talk is about outcomes from a student project which we did in the last winter term, and it was also the topic of serverless applications, as you said, but in a more broader context. But let's have a look what it was all about. So the general problem which we wanted to have a look at is how to migrate existing applications to a cloud-native style. Because for web-based applications, the cloud-native style is nowadays the way to go to build such applications. But organizations also have their existing systems which they might want to migrate to cloud-native style. But it is, as we already heard in the last days, you cannot just put it in the cloud, but you need to transform it, and you need to put a lot of effort into this. So the question is how can you do this? And in the literature, there are already approaches described, but it's very specific and for specific projects, and there's no real general approach to do this which you can follow easily. So the question is, well, what we wanted to tackle is, okay, how can you do this potentially more structured and also more tool supported to support such migration projects? And the idea which we had, or which is also proposed in the literature at some points, is to use model-driven engineering, so that you have models as a first-class citizen in your development projects. And in model-driven engineering, you would differentiate between platform-independent models and platform-specific models. And due to this abstraction to the platform, you can just focus on the models, on what are your key focus, what you want to develop, and you do not have to focus that much on the platform-specific side. So you're getting more independent of technology. But this also comes with an overhead, because you do not only have the code to maintain and develop, but also the models. So ideally, you would try to automate as much as possible and also support this with tools as much as possible. And how this would, how you could apply this to the concrete to a migration project to migrate to a cloud-native application, is that you would have your existing application, your code, and you would have to generate models out of that, which are platform-specific in the first step. Then you would try to get to a high level of abstraction. So what is actually the information you need to transform this, so you get platform independent. And then is the most interesting part, I think, where you then actually try to do this transformation to get a cloud-native application which really uses, which makes most out of the benefits which you have in a cloud environment. And then that would be the next step. Then you would have to, again, get platform specific, so for the actual cloud provider where you want to deploy your application. And out of the models, again, you would then, in the end, in an ideal world, you could then generate the code and it would work. But it could also be possible that you just, first generate some skeletons, and then you have the structure given and can then implement your application again. And so the research question, to sum this up, what would be necessary to get to this vision of a model-driven cloud-native application is, okay, which information and especially which level of abstraction is needed to do this, because you want to abstract from the actual application in the models, because you want to focus only on the task you want to do. So you need to decide, okay, how do you represent this in the models? And which further aspects do you need to include to actually make use of the benefits of the cloud, so to really become cloud native? And what we did in the project was a twofold approach. On the one hand, we had a look at the literature, what there is, and there, because there wasn't nothing specific to this topic, we included multiple things. So on the one hand, existing model-driven approaches for cloud migrations, which is already from previous projects where you did not have this cloud native style. then migration project in general, so from monoliths to cloud native applications, and articles focusing specifically on the architecture transformation approach, so approaches, algorithms to really transform the application. So the literature analysis on the one hand, and on the other hand, we did a manual transformation of the Spring Peddling, which is a small sample application from Spring, showcasing the features, and it's monolithic. So we kind of facified this to get to cloud native style, and we choose FAS as a paradigm because it's the most extreme way to get the most fine-grained components out of the application. Just as a note, it was not the goal to improve the application in any way. The only goal was to focus on the approach, how you could do this. And from that, our goal was to derive then requirements for the platform-specific and platform-independent models to get into the direction of applying a cloud-native, model-driven cloud-native migration approach. So these requirements are also the main contribution which I want to represent, and we structured it according to the model-driven approach which we already saw. So we start with the platform-specific model of the existing application, and what we need to represent there in the model is, as a main part, the application logic. And here we have to decide for the level at which we want to represent it. And because to transform it, the application to a cloud-native style, we ideally also want to decompose it into more fine granular structures. We have to represent the existing monolithic application at a certain level of abstraction. And what you can find in literature, that a lot the level of classes or if you think of object-oriented languages like Java, then classes are used as the level of component which is analyzed. But in other cases also methods, and that what we found in a project also, that for the application has to be built in a very good way that you can classes, but oftentimes you have functionality in one class which you would ideally split up, so you have to go more fine-grained, at least at the level of classes, but better would be at the level of methods. In addition, you also need to consider what databases basically you have, so what storage components, because they go hand in hand with the application, and for making a useful transformation, a useful decomposition, you also have to include that into your representation. And to then also what is used in the algorithms or approaches presented in literature is that you also need some kind of knowledge to base your decisions on. How do you decompose? And it's not enough to only have the code. You also then need to further analyze this. For example, dependency graphs, which are rather easy to construct, but also it would be ideal to also include additional metadata, which is obviously harder to get, but this would help to make a reasonable decision for the transformation. And if this would be modeled, then you would need so for the level of abstraction, it would be important to differentiate between compute and storage components, because because of the statefulness of the storage components, they have an important role. They have to be treated separately. And for the compute component, you would then have one generic component to represent classes and methods, and you would group them to then define these hierarchies again in order to be able to split it up. And further characteristics are necessary to know which classes you should put together, or which components you should put together and separate, and what works. I'll do it a bit fast because that's, and what you would have then is, so the platform independent model would be in general the same for the existing and the cloud native applications, and here you would add another things. For example, then in a cloud native way, we'd also use cloud services from the cloud provider, like for example an authentication service which is already there, and you wouldn't have to implement yourself, just as an example. And finally, you would have to then be platform specific, so decide for a specific cloud provider and which deployment model you would want to have. So that would be the requirements. And there are still additional challenges which I kind of want to skip now because the time is already over, but we can have a talk in the poster session as well. Just to conclude, what the contribution is that it is the basis for an actual realization of such an approach. So the idea is that this could guide an actual realization. But in general, such an approach, it could help to structure and integrate regression, but challenges and complexity do remain, so there's still a lot to do. So thank you, and maybe we can talk about this in the post session.
Thank you.